The purpose of this experience was to create conditions where 4 possible contributors become visible: memory, conflict, novelty, and urgency. Alone, each may remain manageable. Together, they may influence how stable information remains. The first stressor is memory. Working memory is temporary, active maintenance. It lets us hold information while manipulating something else. Baddeley described it as a limited capacity system for temporary storage and manipulation. In the test, memory was stressed because each answer had to remain available while new tasks continued to arrive. The second stressor is conflict. When the word blue is written in green, reading competes with seeing. Miyake and colleagues describe inhibition as the ability to suppress dominant or automatic responses. So the task is not only naming a color, it is suppressing the answer your brain produces first. The third stressor is novelty. When a task is not automatic, it requires more active processing. Sweller's cognitive load theory argues that conventional problem solving can consume processing capacity that would otherwise be available for learning or stabilization. Rearranging letters is simple. The challenge was not the letters themselves, but adapting to a new rule while maintaining previous information. The fourth stressor is urgency. Paas and Van Marienboer proposed that time pressure compresses information processing capacity. Under limited time, each new question must be processed while previous answers remain relevant. Under these stressors, one leading theory becomes interesting. Barrouillet's time-based resource sharing model proposes that processing and maintenance compete for the same attentional time. Maintaining information is not passive. Information must be refreshed. But every time attention is redirected towards solving the next task, less attentional time remains to stabilize what was already active. The answers may not disappear. They may simply receive less opportunity to remain stable. This gives us one possible explanation. Simple questions became difficult to remember, not because they were individually difficult, but because stabilization could not keep pace with incoming demands. We propose that memory, conflict, novelty, and urgency may compete for attentional maintenance. And one leading theory suggested that under these stressors, processing and maintenance compete for the same attentional time. But the experience lasted only a few seconds. So another question emerges. What happens when this cognitive demand is sustained? One possible perspective comes from Bernardin and colleagues. Their work explored how prolonged cognitive activity affects both performance and the subjective experience of mental effort. Their findings suggest that as cognitive activity continues, subjective mental effort increases over time. Not necessarily because the task changes, but because sustaining cognitive activity appears to carry a growing subjective cost. Kurzban and colleagues proposed one interpretation of this increasing subjective cost. Their opportunity cost model suggests that mental effort reflects an ongoing evaluation of whether maintaining the current activity remains worthwhile relative to alternative uses of cognitive resources. Under this account, subjective effort becomes a signal that continuing carries an increasing cost. In short, the brain may begin signaling that maintaining the current activity is becoming less worthwhile relative to alternatives, increasing the tendency to shift toward other activities. Under sustained cognitive demand, if maintaining the current activity becomes progressively more costly, alternative paths may become increasingly attractive. Under these conditions, divergence may emerge, not as failure, but as a gradual shift away from the initial objective and its intended closure. The original target may remain present, yet become less tangible, making closure increasingly difficult to define. So what is the takeaway? When memory, conflict, novelty, and urgency remain active over time, sustained cognitive load may increase the probability of diverging from the initial objective. As this divergence grows, closure may become less likely, increasing the probability of leaving the task unfinished. This is not presented as a new theory, but as a proposed synthesis built from existing research. It will serve as a proposed baseline to further explore human-AI interaction when the cost of maintaining direction is not equally shared, a condition that can also be referred to as asymmetry.